Hi, my name is Xander Powell, and this is my video explaining linear regression modeling. To begin, linear regression modeling builds on the idea of y equals mx plus b, or the equation of a line. The whole point of linear regression modeling is to create a best fit line to a set of data points. Doing so helps find relationships between variables, or the lack thereof. As well, linear regression modeling can be used for predictive-based statistics. If a certain piece of data is needed but not a part of the original data set, the linear regression model can predict where that unknown data point might fall on the graph. Now this slide shows multiple data sets that I had collected during a chemistry lab that measured absorbance over time. Now in this case, we took the natural log of the absorbance to create a more linear looking data set to use with our linear regression modeling. So now we can see that each of these data sets possess a negative m value, and this means that the relationship that exists between the increasing independent variable leads to a decrease in the dependent variable. As well, we can see that each coefficient of determination for the data sets, or the r-squared value, is extremely close to 1. Now this value indicates how strong of a relationship exists between the independent and dependent variable. In this case, with the value being close to 1, there is a strong relationship. On the other hand, if the value was 0, it would be safe to assume that the data and the variables included in that data are not related to each other, and that no relationship exists. In the article I had cited, Simulation of a Hydrogen Natural Gas Engine and Modeling of Engine Operating Parameters, the research team included the use of multiple linear regression modeling to find a relationship between engine operating variables, including but not limited to power, torque, carbon monoxide, and nitrogen monoxide levels. They used the included independent variables to test the relationship: dihydrogen percentage, engine speed, ignition timing, and injection timing. In this case, to model with multiple linear regression, we create a three-dimensional x vector that models all of the independent variables together. In doing so, we can use this vector as an analogy to what would be the x-axis for a regular linear regression model. Having this vector allowed the research team to find a dependent variable vector and determine the relationship between engine operation and the various independent variables. All in all, it's important to use the various forms of linear regression to model relationships and determine correlations between variables. Without these modeling techniques, one might find that a relationship exists where in reality none do, or vice versa. Thank you for your time.